Hello everyone, welcome back to my channel IGCSE Biology Help. In today's video, I'm going to be solving the chemistry paper 6. This is for both core and extended students, February-March 2024. This is of course variant 2 because all the February-March exams are variant 2 already. So make sure to subscribe to my channel and like my videos so you can receive more content like this. And let's start solving. Question number 1 says calcium carbonate is an insoluble solid. Calcium carbonate can be made by adding excess aqueous calcium chloride to aqueous sodium carbonate, and this is the equation over here. A student makes a sample of calcium carbonate. The first two samples of the method are shown in figure 1.1. So step 1 is adding excess aqueous calcium chloride to aqueous sodium carbonate, and here is they drew a diagram to show that, and then they stirred or mixed the mixture. So question A says name the item of apparatus labeled A in figure 1.1. This is over here. They are pointing at a glass rod. So glass rod is used, which is question B. They're asking about why the mixture is stirred in step 2, which is here, to evenly distribute the substances and to mix the substances together. So mixing, if you just put for example salt on water and you just leave it there, then there will not be evenly distributed substances. It will just it will not be mixed. So you have to also stir so that there is an increase in the kinetic energy as well, so that they can mix together evenly. C says after step 2, the student filters the mixture to remove the solid calcium carbonate formed and collect the filtrate. Draw a labeled diagram to show the apparatus used for the filtration. So first of all, you have to draw a conical flask like this one, and you have to draw a filter funnel, and you have to make sure that you draw also a filter paper inside. You have to show that you drew it, and of course the sand inside, or the solid calcium carbonate inside over here. So you have to also draw that there is filtrate over here. This is the filtrate. D says the solid calcium carbonate obtained by filtration is not pure. Identify one substance other than water which is mixed with calcium carbonate and makes it impure. Calcium chloride, which is CaCl2, or sodium chloride. So you can write it down in either like word form, or you can write it down in like the chemical form like that. So II says describe how the substance you have identified in Di can be removed from the calcium carbonate. You can filter again, or you can wash that with water so that you can remove any impurities, and you can also add the residue to water again. So there is also many other ways, but mainly you can wash it with water and filter it again. Describe a test that the student can do to filtrate on the filtrate obtained in C, which is over here, which was the solid calcium carbonate. So they want a test on the solid calcium carbonate to show that calcium chloride was used in excess. Give the result the student obtains if the calcium chloride is in excess. So there is two tests you can make. There is a test for either carbonate ions or calcium ions. So carbonate ions, you can add the dilute hydrochloric acid or nitric acid, or any acid, and any acid from the 3 over here. And if it does not fizz or bubble, then it was used in excess. So test for calcium ions, add aqueous sodium hydroxide or aqueous sodium carbonate, and there can be a white precipitate, or you can filter it. So there is a solid residue that should form if it was used in excess. Number two, a student investigates the reaction between aqueous sodium carbonate and two different solutions of dilute hydrochloric acid labeled A and B. The student does three experiments. Experiment one was rinsing a burette with distilled water and then with dilute hydrochloric acid A. Rinse a conical flask with distilled water and fill the burette with dilute hydrochloric acid A. Run some of the dilute hydrochloric acid out of the burette so that the level of dilute hydrochloric acid is on the burette scale. Record the initial burette reading and use a measuring cylinder to pour 25 centimeter cubed of aqueous sodium carbonate into the conical flask. Add 5 drops of methyl orange indicator to the conical flask. Stand the conical flask on a white tile and slowly add dilute hydrochloric acid A from the burette to the conical flask while swirling the flask until the solution becomes orange. Record the final burette reading, and experiment 2, refill the burette with dilute hydrochloric acid A. Run some of the dilute hydrochloric acid out of the burette so that the level of hydrochloric acid is on the burette scale. Record the initial burette reading. Empty the conical flask and rinse it with distilled water, and measure this measuring cylinder to pour 25 centimeter cubed of aqueous sodium carbonate into the conical flask. Add 5 drops of thymolphenolphthalein indicator to the conical flask. Stand the conical flask on a white tile. This is to see the color. Slowly add dilute hydrochloric acid A from the burette to the conical flask while swirling the flask until the solution becomes colorless. Record the final burette reading. So experiment 3 was repeating experiment 1 but using dilute hydrochloric acid B instead of dilute hydrochloric acid A. Question A, use the burette diagrams in figure 2.1, 2.2 and 2.3 to record the readings for experiment 1, 2, and 3, table 2.1, and complete table 2.1. So here we have all of the burettes. So initial reading was before the experiment and final reading was after the experiment. So you have to record over here the values. So before the initial, you're going to draw, or they already drew a table for you. So you have to write down in experiment 1 the final burette reading. Over here it was 26.2 over here. So this is for example how you read it. This is inverted, by the way, so be careful. So you have to write each one of them down for experiment 1, 2, 3. And then you have to find out the volume of dilute hydrochloric acid added. This is by subtracting the final minus the initial. So this is going to give you 25.4 centimeter cubed. Don't write down the centimeter cubed because they already wrote it down over here in this place. So don't write it down because they already wrote it down. They might detect marks if you do such thing. BI, state which solution of dilute hydrochloric acid A or B is more concentrated. Explain your answer. So of course it's actually A. This is because over here if we compare, they in experiment 1 they needed 25.4 volume of hydrochloric acid so that the experiment can start, but in experiment 3 they needed 38.1, and this was using the same like everything, the experiment was the same, but they used the hydrochloric acid B instead of A, so it is actually more concentrated than B because it needed less amount to be used. So deduce how many times more concentrated this solution of hydrochloric acid is than the other solution of dilute hydrochloric acid. This is 1.5 times. You're going to do 38.1 divided by 25.4 on your calculator, and you're going to get 1.5. This is how you find out how many times it is more concentrated. CI, compare the volume of dilute hydrochloric acid A used in experiment 1 to the volume of dilute hydrochloric acid A used in experiment 2. It is actually twice as much volume was used in experiment 1 compared to experiment 2, because we can see here that in experiment 1 there was 25.4 centimeter cubed used, but in experiment 2 it was like less than half of that amount. So it is actually maybe more than twice that much, you can say that, but you can get the mark as long as you say twice as much. So double I says, deduce the volume of dilute hydrochloric acid B required to reach the end point if experiment 3 is repeated using thermal phthalate indicator instead of methyl orange indicator. Use your answer in CI to help you. So in this question, you're actually going to compare using thermal phthalate indicator instead of methyl orange. Methyl orange was used in experiment 1. Over here, they used methyl orange indicator, and in experiment 1, they used double the amount that was used in experiment 2. Experiment 2 used thermal phthalate over here. So thermal phthalate, we can say that it's more concentrated, therefore it will use less than half of the amount that was used in experiment 1. So you're going to be dividing this number, which was experiment 3 number. This was using methyl orange. So you're going to be dividing it over 2 because, as I said, thermal phthalate is more concentrated. So you're going to be dividing it over 2. You're going to be getting 19.5 or 19.1. This was according to over here. When you minus the number, you can get like a different number, I don't know, but the right answer should be 19.05. But it's also okay if you got 19.1 centimeter cubed. You're going to get a mark just for writing centimeter cubed, so make sure to write the units, or else you're going to be deducted 1 mark. G says, at the end of experiment 3, the burette is rinsed with distilled water and then with dilute hydrochloric acid B. Identify the substance removed from the burette when it was rinsed with distilled water at the start of experiment 3. This was actually the dilute hydrochloric acid. So they have to remove it so that there is no extra acid added in there, and there is accurate results. So describe how the result of the titration would change if the burette was not rinsed with dilute hydrochloric acid B after it has been rinsed with water. So if it was not rinsed, then there will be more acid needed because there was excess hydrochloric acid in the burette. So more acid would be needed. That's the problem. So you have to wash it so that there is more accurate results, and more acid would be needed, so it will not be accurate. It should need less than that. So we have to always wash it to remove impurities or extra substances from the past experiment. So explain why the conical flask is not rinsed with aqueous sodium carbonate after it is rinsed with water, because this will increase the volume of aqueous sodium carbonate. You have to rinse it with water. You have to rinse it with water only. The E says, explain why a white dye is used during the titration so it is easier to observe or see the color change. White dye can show us clearly the color change compared to if you put it on another color. So it is also, it's not very accurate. You should use a colorimeter. F says, describe the effect on the result of warming the aqueous sodium carbonate used in experiment 1 before carrying out the titration. Explain your answer. There will actually be no effect because the volume or moles or the amount or concentration of sodium carbonate does not change. So the warming up of the aqueous sodium carbonate will actually not make a difference because you did not change the moles or the volume actually, or concentration or anything that might really affect the experiment. So that was the answer. 3. A student tests 2 substances, solid C and solid D. Test on solid C. Solid C is ammonium iodide. The student dissolves solid C into water to form approximately 3 equal portions. So right now we're going to see the student, you're going to be either testing ammonium or iodide. So we're going to see over here, they added, if there is, for example, if there's something that they added over here, it doesn't need to react with both of the substances so that you can get an answer. No, you can only see if it reacts with either ammonium or iodide, and if it does, then you are going to write down the answer. So it it the student added 1 centimeter cubed of dilute nitric acid followed by a few drops of aqueous barium nitrate. So let's see the test for ammonium. It's actually at the back. All the tests are now written at the back of the exam, if y'all can see. So over here, the test for iodide, they add nitric acid and silver nitrate. This was not actually added in the question. They added barium nitrate. So this is it's supposed to give us yellow precipitate, but we will not get it because they added barium nitrate instead of silver nitrate. Now let's see for ammonium or ammonia. Ammonium, sorry. Ammonia produced on warming, they did not warm it or add sodium hydroxide. So there's going to be no change. Over here we're going to write down no change. So B says to the second portion, or that it's the same thing. So they added 1 centimeter cubed of dilute nitric acid followed by a few drops of aqueous silver nitrate. So this will produce yellow precipitate because this is actually the test for iodide, and we have it over here. It's going to produce yellow precipitate, so you're going to write down that answer. So you're basically copying down the answers from the back, so it's very easy to get marks in this section of the exam. It doesn't require studying at all actually, or minimum studying. So make sure to focus while you're solving these questions. To the third portion of solution C, the student adds an excess of aqueous sodium hydroxide. So actually in C there's going to be no change because they did not heat it. If they heated the solution, then we will get ammonia, but over here there was no heating, so there is no change. Now the student warms the product from CI and tests any gas given off observation. So there is going to be ammonia. Now they heated the solution, so there is going to be ammonia, and we know that ammonia, it will turn red litmus paper it to blue. So let's see over here at the back, we know test for ammonia. Over here it will turn damp red litmus paper blue, so this is going to be our answer. So we're trying to find out what solid D is, what components it has, what elements it has. So do a flame test on solid D. It gave us a yellow colored flame, which indicates that we have sodium, and hold a strip of anhydrous cobalt to chloride paper at the mouth of the boiling tube, and we know that if it changes color, then we should get pink over here. So this answers our first question. State the final color of the cobalt to chloride paper in test 2, which is pink. It's not written in the back of the exam over here in the notes, but you should know it. Now dissolve the remaining solid D in water to form solution D. Divide solution D into 3 portions, and I add aqueous ammonia dropwise until in excess it formed green precipitate, which is insoluble in excess. This is actually iron 2 plus, so make sure to write down the 2 plus because there is iron 3 plus as well. To the second portion of solution D, add a piece of aluminum foil and about 5 centimeter cubed of aqueous sodium hydroxide. So this actually sounds like the test for nitrate over here. They add aluminum foil and sodium hydroxide. So if there was nitrate, there would be ammonia produced. And over here they said that the red litmus paper remained red, so that means that there was no ammonia. If there was ammonia, then it would change to blue. So that was not present. Now to the third portion of solution D, add about 5 centimeter cubed of dilute nitric acid and bubble any gas formed through lime water. So there was lime water becomes milky. That means that there was carbon dioxide, and this was the test for carbonate. So over here in carbonate, we know that the test should be like that. Over here, and this is the carbonate test. They added dilute acid and then test for carbon dioxide gas. This was by bubbling through lime water. So carbon dioxide produced and there was effervescence. So this was present there. So far we have carbonate, we have iron 2 plus, and we have sodium. So as I said, the final color should be pink of the cobalt 2 chloride paper. And state what ion the observations in test 4 show is not present. This was actually nitrate because, as I said, this was the test of nitrate. Identify the gas produced in test 5. This is actually carbon dioxide because at the back over here it says so, and we know that carbon dioxide will produce, it will turn lime water milky over here. For the next question, it says identify the 3 ions. So as I said, we have carbonate and we had iron 2, or you can also say chromium because both chromium and iron 2 plus, they form green precipitate. So we don't know, they didn't state if it was soluble or insoluble, so it should, if you wrote down either iron 2 or chromium 3, then 3 plus, then you would get the correct answer. So it also had carbonate, as I said. So let's see, this is our last question, which is the experiment question. If you want help in the experiments, then you should check out my paper 6 video that I did. It was very helpful for students who were struggling for the in the experiment questions in either biology or chemistry or any subject. It should help you know how to form and answer this type of question. If you're having trouble, you can check that video out. You'll find it on my channel. So the experiment says when excess dilute sulfuric acid is added to the solid zinc, hydrogen gas and aqueous zinc sulfate are made. So plan an experiment to show that copper is a catalyst for this reaction. Your plan should include how the results of the experiment will show that copper is a catalyst for this reaction. You are provided with zinc powder, dilute sulfuric acid, and copper powder, and common laboratory apparatus. So first of all, you can write it down in either points, or you can write down as numbered or paragraphs. So use a known or stated or fixed volume of dilute sulfuric acid. You have to write down either, you have to say how much you used, for example 500 milliliter or whatever you have to say. You have to state the volume. Now add a known or measured or stated fixed mass of zinc to that sulfuric acid and measure time to collect a set or of volume of gas. So first of all, for example, let's say that you added 500 milliliters of sulfuric acid to, for example, let's say 50 grams of zinc, and you have to measure the time taken to collect a certain volume of gas, or you can also measure the time taken until there is no more gas that was produced from this experiment. So you have to measure the time taken until there is also, you can also measure the time taken until no more mass loss, or the time until no more gas collected, or you can also measure mass loss or gas volume in a set time. So you also have to say that you used a conical flask or a test tube or a boiling tube to actually put the dilute sulfuric acid in and do the experiment in. And you also have to say that you used gas syringe or inverted measuring cylinder to collect the gas. Now you also get a mark for saying that you repeated the experiment, and also add copper as well as zinc. So copper should act as a catalyst and increase the reaction time without being itself changed. So we're going to see if that happens, then it is a catalyst. Filter out the copper from the solution after you collected all the gas, and weigh the copper. If the copper weight is the same, then it is a catalyst. And also if there is a change in the experiment time, and if it took less time, then it is a catalyst. So this is how you know if copper is really a catalyst or not. And this is the end of our exam. Thank you all for watching. Make sure to like and comment down if you have any questions, or if you want me to solve a specific paper. And make sure to subscribe and share this video if it was useful, or if you actually learned something. Good luck with your exams.